Okay, ladies and gentlemen, what we're doing here, we're looking at the section 2.3 lesson plans for Math 1033. The main concept in this section involves slope. And basically when you're thinking about the slope of a line, you're measuring its degree of tilt. That's a very good gut level way of thinking about what slope is. So without getting real specific yet, if I ask you to draw a line with a positive slope, you're going to be drawing a line that would look like from left to right you're going uphill. When I ask you to draw a line with a negative slope, you're going to be drawing a line that from left to right would look like you're going downhill. When I ask you to draw a line with a zero slope, you're going to be drawing a perfectly horizontal line. Now, a horizontal line does have a slope. It is equal to zero. Okay? So if someone asks you, is there a slope, the answer is yes, because the correct answer is zero. If you're on a treadmill at the gym and you haven't tilted it yet, it's just flat, that treadmill has a slope of zero. Okay, so it's almost like you're on a flat road without a hill or a valley. You got it? Now, a vertical line is completely different. A vertical line has no slope. Its slope doesn't even exist. That's why we say there is none. We sometimes say it's undefined. The way I teach my students to remember about vertical lines and the fact that they do not even have a slope, notice a vertical line the way it's pointing. That is not the way you want to see your cruise ship. Okay? Leonardo DiCaprio would be standing on the very top of it going, oh, hold on, hold on. You with me? Not the way you want to see it. This is the way you want to see your cruise ship. So let's keep a cruise ship with the slope of zero, and let's not have it pointing head down going into the water. Got it? Good. Now, one last question. Which of the following four lines is not a function? The vertical line is not a function because it fails the vertical line test. If you put a vertical line on top of a vertical line, it will cross it more than once. In fact, it crosses it all the time. So if I asked you to draw a line for me that was not a function, the only kind of line you could draw would be vertical. Okay, now let's tighten up the concept of slope a little bit more. Some of you have been taught that slope is rise over run, which is a good thing to know. Slope can be measured as a fraction. The top number represents the change in y, which is the up or down movement. It's the way an elevator goes. And the run is the change in x, so that's basically from left to right. When I write this triangle in front of the y, that means change in y. And when I write the triangle in x, that means change in x. So slope is really the change in y divided by the change in x. So, alright, I'm sorry for that. What we need to do here, let's continue. Slope is a fraction. Change in y goes on the top, change in x on the bottom. Okay, come with me to this line. To find the slope of a line, I need to pick 2 points on the line. So I'm going to pick the y-intercept and I'm going to pick the x-intercept because they're very clear to see. The change in y, if I was moving along the y-axis to get from one point to the other, if I started at this top point, I would go down 3 and then I would go 5 to the right. That's why my change in y is negative 3 because I went down, and my change in x is a positive 5 because I went from left to right. Negative 3 divided by 5 would be negative 3/5. So one way to find the slope of a line is by counting. Alright? Now it's not the best way to always do it because sometimes, the graph is very, the numbers aren't pretty. But I tried to give you an example here where you could actually see what slope was. And of course, you can do it by counting if there are two very clean points to use. Okay, continue with me here. Let's look at another example. Alright, let me scroll back up. Here we go. Here's another example. Find the slope of the line containing the points -3, -2, and -5, comma 8. Now, by definition, slope is the change in y divided by the change in x. Now, in order to find the change in y, you are going to subtract the y values. My first y value is -2. My next value is 8. So notice I have -2 minus 8. To find the change in x, I do the same thing. My first x value is -3. My next x value is -5. -3 minus a -5. Very important to put those parens. We end up with -10 on the top. We end up with a +2 on the bottom. Therefore, this line has a slope of -5. So, anytime you're asked to find the slope of a line between 2 points, you're really applying this formula. Slope is a fraction. Change in y is always in the numerator. Change in x is in the denominator. To find the change in y, you subtract the y values. Y sub 2 minus y sub 1. Change in x would be x sub 2 minus x sub 1. Now, I had a student ask this in class the other day. Is it okay to start with the first y value and subtract the second x value from it? Sure it is, as long as you're consistent with what you do with x. So if you start with the y value from point 1, then you have to start with the x value from point 1. So you just have to be consistent in your order. Okay? Alright, now, here we have a problem. If I ask you to find the slope of this line, notice it says if it exists, so that's probably a hint. 9, -2 is one ordered pair, and 9, 8 is the other. Change in y goes on the top, change in x goes in the bottom. My first y value is -2, my second y value is 8. I have -2 minus 8. My first x value is 9, my next x value is 9. 9 minus 9, we've got a problem. 9 minus 9 is 0. What you need to remember from arithmetic, if the denominator becomes 0, in other words, if you end up dividing by 0, you've got garbage. If you have a calculator in front of you right now, if you tried to put -10 divided by 0 in your calculator and hit enter or equals, it would tell you error. A denominator cannot become 0. Division by 0 is not allowed. Therefore, this slope does not exist. Now let's tie this in. What kind of slope did I tell you earlier? What kind of line did I tell you did not exist, did not have a slope? A vertical line. And what would tie in here? If you graph these two ordered pairs, just to prove what I'm saying, these two ordered pairs would connect and form a vertical line. So it shouldn't be a shock that the slope does not exist. Okay, that's enough for this video. I'm going to continue on another part. So we'll call this 2.3 part 1.